This is Caitlin Nguyen, and today is Friday, April 27th, 2018. And today I am going to do my vlog about a math problem. So I'm in Math 3C, which is Calculus for Life Science students. And in section 7.3, we've been learning about mean and variance. And the problem that they asked us to do, or that I'm doing for you, is number 20. And the instructions are to compute the variance of the PDFs. And the PDF given to us is the function f of x is equal to x times e to the negative x power for all x is greater than or equal to 0, and f of x is equal to 0 elsewhere. So another way to write this function would be to write it as a piecewise function that looks like this. Here, OW stands for otherwise or elsewhere. So we'll start with some basic definitions. A probability density function, or a PDF, is a piecewise continuous function f of x such that 1. F of x is greater than or equal to 0 for all x, that is, the probabilities are non-negative, and 2. The total area under f of x equals 1, that is, the area under the histogram is equal to 1. So this question asks for the variance, and the variance is given by this equation below, where P1, P2, all the way up to Pk is defined as the relative frequencies, x1, x2, and x all the way up to xk are distinct values, and the mean is the weird u thingy. Another way to calculate the variance is to take the integral from negative infinity to infinity of the distinct variable minus the mean, all squared, times the function f of x dx. So in order to find the variance, you have to first find the mean. And to find the mean, it's essentially the sum of all the probabilities, P1 up until Pk, times the values x1 up until xk, which can also be written as the integral of the problem. So to calculate the mean, you set an integral from negative infinity to infinity of x times the function f of x d of x. And then to find this integral, you have to split it up because you can't take the integral from negative infinity to infinity by itself. So you split the integral up into negative infinity to 0 of x f of x dx plus the integral from 0 to infinity of x f of x dx. And because the problem states that f of x is equal to 0 elsewhere besides x is greater than or equal to 0, the first integral cancels out and becomes 0. So you are left only with the integral from 0 to infinity of x times f of x dx, and then you plug the function in. So that integral is essentially the same thing as finding the limit from t to infinity of the integral from 0 to t of the function multiplied out, which would be x squared times e to the negative x power dx. As you can see here in the green and in the pink, you have to do integration by parts in order to find the answer. Once you finish the integration by parts, you take the result that you got, which would be negative e to the power of negative x times x squared plus 2x plus 2 plus c, and plug it back into the original integral, which would be the limit of t to infinity of the integral of 0 to t x squared e to the negative x dx, and just substitute it in. You thus find that the mean is equal to 2. Now that you've found the mean, you can plug that in to find the variance. So you plug it into the integral from negative infinity to infinity of a specific value minus the mean, all squared, times the function f of x dx. And since everything before 0 is equal to 0, you cancel that out, and so you have the remaining, the integral from 0 to infinity of x minus 2 all squared times the function x times e to the negative x of dx. And from there, you just change that to the limit as t approaches infinity of the integral from 0 to t of the function that you just had previously all multiplied out, which would be x cubed times e to the negative x minus 4x squared e to the negative x plus 4 times x times e to the negative x dx. Now this problem would be much easier to solve if you split it into 3 parts. So the first part would be the limit as t approaches infinity from 0 to t of x cubed times e to the negative x dx minus 4 times the limit of t to infinity of from 0 to t of x squared times e to the negative x dx plus 4 times the limit from t to infinity from 0 to t of x times e to the negative x dx. So to solve this equation, we'll start by breaking it down to 3 parts. The first part, we have to use integration by parts again in order to find what the integral of x cubed e to the negative x dx is equal to. And that is equal to negative e to the negative x times all of x cubed plus 3x squared plus 6x plus 6 plus c. And then for parts 2 and 3, luckily, we figured that out while doing the mean, so you just take those and plug it back in into the original equation. So now the final equation that you're left with is the limit as t goes to infinity of negative e to the negative x times parentheses x cubed plus 3x squared plus 6x plus 6 evaluated at x equals 0 and t minus 4 times the limit as t goes to infinity of negative e to the negative x times parentheses x squared plus 2x plus 2 evaluated from x equals 0 to t plus 4 times the limit of t as t goes to infinity of negative e to the negative x times x plus 1 evaluated at 0 and t. Once you evaluate the equation, you find that the answer for the variance is also equal to 2.